This is Stoichiometry Test Review 5 and 6. In number 5, they're asking 9.34 grams of zinc reacting with hydrochloric acid, and how many grams of zinc chloride will be produced. So we need to write our chemical equation. We have zinc plus hydrochloric acid. Remember that when it's hydro, it's binary, so it's just H and Cl. And it produces zinc chloride. Zinc is a positive 2 ion and chlorine is a negative 1 ion. And then, of course, we have hydrogen that bubbles out, and hydrogen is a diatomic. So to balance this equation, all we need is a 2 right here. I'm going to put my given over 1, so 9.34 grams of zinc. And I'm immediately going to write this unit, grams of zinc, below the line, and the only thing that can convert to is moles of zinc. Then I'm going to put moles of zinc below the line, because whatever I put here, I automatically put here. And I need to convert this zinc to zinc chloride, so that's what I'm going to choose to do my mole conversion to. And then I'm going to write moles of zinc chloride down here, and then I need to convert it to something that is measurable, which is grams of zinc chloride. Filling in my numbers, I look at the periodic table, and the mass of zinc is 65.38. Periodic table is always in 1 mole. To do my mole to mole conversion, I have to look at the number in front of zinc. That would be a 1. My number in front of zinc chloride, that would also be a 1. And then I go add the masses of 1 zinc and 2 chlorines, and that gives me 136.286. Multiply the tops, multiply the bottoms, divide the top by the bottom to get 19.4694. My question has 3 significant figures, so I can only have 3 significant figures. I look 1 past. That number right there tells me that I need to round the previous number up, which gives me 19.5 grams of zinc chloride. Question number 6 is asking me to do 16.3 grams of magnesium and 4.52 grams of oxygen. Now, since I have masses for both of my reactants, this one I already have my reaction written out, this is going to have to be a limiting reactant question. So I have to treat 16.3 grams of magnesium separate from 4.52 grams of oxygen. So I'm going to write 2 stoichs. 16.3 grams of Mg over 1, and then I'm going to put grams of Mg here. The only thing grams can go to is moles. I immediately write moles of Mg here, and I'm being asked eventually to find grams of magnesium oxide. So I'm going to go ahead and choose to do a mole to mole conversion to magnesium oxide. And then whatever I write above the line, I immediately have to write below the line, and I need to convert this into something measurable. Right now, all we have done is magnesium oxide. Going back to my periodic table, I see that the mass of magnesium is 24.305. Periodic table is always in 1 mole. The number in front of magnesium is 2. The number in front of magnesium oxide is also 2. Then I find the mass of magnesium plus oxygen, which gives me 40.304. Periodic table's in 1 mole. So I'm going to do the math, multiply the tops, multiply the bottoms, divide the top by the bottom. 27.0296. I do this again, but this time starting with the 4.52 grams of oxygen. The only thing that grams can be converted to is moles. I go from moles of oxygen again. I want to go to the same product so I can compare them. And then I'm going to fill in the moles of MgO here to grams. Now I already did this math, so I'm just going to use that math again for my 40.304 grams of magnesium oxide. So the mass of two oxygens is 31.998. It's in 1 mole. My mole-to-mole ratio, the number in front of oxygen is only 1, and in front of MgO is 2. Multiply the tops, multiply the bottoms, divide the tops by the bottoms, and I get 11.3866. This tells me that I can only produce 11 grams of the magnesium oxide. The reactant magnesium is going to run out before, the reactant magnesium is going to be excess, and my oxygen will run out before magnesium. So the limiting reactant is O2, and it will only produce 11 point, now remember 3 sig figs, so 3, that should be 38. 11.38, so that tells me that I need to round my 4 up.